Assalamu alaikum. This is the lecture related to summary of lecture related to combined circuits, and I hope this will enable you to understand it more thoroughly. Okay, the combined circuit are also known as series parallel circuits, and you can see a diagram of this circuit. We have a battery here which is of 12 volt and 1, 2, 3 and 4 1 kilo ohm resistors connected in a combined circuit. This is a circuit diagram with 4 resistors connected in a combined, that is a series circuit. So basically what happens here is that for analysis you need to know all the characteristics found in the series section as well as in the parallel sections, and they apply on this circuit accordingly for the analysis. Okay, the current flows from here. It then goes in this direction and in this direction, then follow this path, and here it combines and goes back to the battery. This is how it works. So for the analysis purpose we need to understand the direction of flow of current, and then we need to understand also how the current is dividing in this circuit, which you can see as I am showing on through the arrows. Okay, so we can see that this resistor is basically dividing the current at this node, and it is going, some of it is divided and according to the resistance goes in this direction and part of it goes in this direction. Here you can see the same current flows from this resistor as well as this resistor. So these two resistors are in series. Okay, at this node the current from these two resistors and this one are recombined and flows through this fourth resistor and into the battery. So we can see we have two parts. One is the division and the other is here, which is series, and then again a combination of both the currents. So what we need to do is to understand how we are going to solve it. So first what we are going to do is we are going to solve it because we need to find out RT, and for RT first we will solve these two resistors for series, and we know the characteristics of series circuit. As we can see here, the series circuit characteristics for resistance is RT is equals to R1 plus R2 plus R3. So we are going to just add these two resistors and name it with a different resistor with a different label, that is RA. Okay, so for solving this circuit, first we will label these resistors as R1, R2, R3 and R4, and as we can see these are two in series, so we are going to solve R3 and R4 by using the series characteristic formula. RT is equals to R1 plus R2 plus 3 and RA will be equal to R3 plus R4. Now you can see that once you have RA, then we have R2 and RA in parallel. As you can see in the diagram, now RA has replaced R2 and R3 which were in series, so we have another new equivalent circuit with R1, R2 and RA, and now we can change these values also. Okay, so we can see that R3 plus R4 solved in series gives you 1 plus 1 equals to 2K, and here it is, RA is equals to 2K, and this is the new equivalent diagram which is now showing R1, R2 and RA, which is the combination of R3 and R4. So we can see now R2 and RA are in parallel. So using the parallel characteristics we can solve it, and for that we will So we have Ra 2 kilo ohms, which was achieved using Ra is equals to R3 plus R4, as R3 and R4 were in series. Now we are going to see that R2 and Ra are in parallel, so we are going to solve them accordingly. 1 upon Rb is equals to 1 upon R2 plus 1 upon Ra. 1 upon R2 is 1 upon 1 plus 1 upon Ra is 1 upon 2, and if we solve it, 1 plus 0.5 gives you 1 upon Rb is equals to 1 upon 1.5, and if you divide 1 divided by 1.5, you should be getting something, it's 0.6 k. So we have 0.6 k is raised to power 1, which means 0.6 k. So Rb is 0.6 k. After solving R2 and Ra in parallel, we have a new Rb equivalent resistance of 0.6 ohm. Now we can see this equivalent circuit which has R1 and Rb, and now we can easily find out Rt by simply adding R1 and Rb. So we can do that by using this formula. Rt is equals to R1 plus Rb in series, because they are in series, as you can see, and here we can just add them up. Rt is equals to R1 plus Rb, which is 1.6 kilo ohms. So Rt here is 1.6. Okay, so this is an equivalent circuit with Rt is equals to 1.6 kilo ohms, Vt is equals to 12 ohms, and this is the final Rt which we needed to calculate It using the Ohm's law. And we can then move on to find out individual voltages and currents at all the 4 resistors.